Welcome back, students. This is a session 5 from the playlist of system of particles and rotational motion. The topic for this session is the motion of center of mass, and this session is in a continuation of the session number 4, in which we have studied about the motion of the center of mass, and we have also derived the equation for the velocity and the acceleration of the center of mass. So here the question is, two particles A and B, initially at rest, move towards each other under the influence of the mutual force of attraction. So at the instant the speed of A is v and the speed of the particle B is 2v. The speed of the center of mass of the system is. So there are 4 options given here, and we have to find the correct one. And this question is basically based on this topic, that is motion of the center of mass. And this question was also asked in the IIT-JEE mains examination. So here the first point is that these two particles, that is A and B, they are moving towards each other under the influence of the mutual force of attraction. So the force on the particle A, say Fa, this will be equal to Ma into the acceleration of this particle A, and similarly the force on the particle B, this will be equal to mv into the acceleration of the particle B. So I have denoted here the mass of the particle A as ma and the acceleration of the particle A as aa, and the mass of the particle B is mb and the acceleration of the particle B is ab. Now at the instant the speed of A is given as v and the speed of B, that is the speed of the particle A is v and the speed of the particle B is 2v. So this equation can be further written as Fa is equal to ma dot v upon t, and the force on the particle B, this is equal to mb, and here at the instant the speed of the particle B is 2v, so this can be written as 2v upon t. Okay? So here v is the velocity or the speed of the particle A, and this 2v is the speed of the particle B, and t is the time. Now since these two particles are moving towards each other under the influence of this force of attraction, therefore Fa will be equal to Fb, and this is the most important step of this question. That is, whenever two particles or two bodies, they are moving towards each other under the influence of an attractive force, then in that case the force on a particle, let us say A in this case, will be equal to the force on the particle B. So this is the most important step in this question, and if Fa is equal to Fb, then Ma into V upon T, this will be equal to mb into 2V upon T. So from this equation I am getting that Ma is equal to 2 times mb. That is, the mass of the particle A should be equal to 2 times the mass of the particle B, and so this is the relation which I have got by equating Fa is equal to Fb. Now in the previous session, that is in the session number 4, we have learned that the velocity of the center of mass is given by mv is equal to m1 v1 plus m2 v2 plus and so on. This is equal to mn vn. That is, here the m, this capital M, is the mass of the system of particle, v is the velocity of the center of mass, and this is equal to m1 v1, m2 v2 and so on, where v1 is the velocity of an individual particle having a mass m1. Similarly, v2 is the velocity of another particle having a mass m2. And so if there are only two particles, in this case there are only two particles, so the total mass of this system of particle will be equal to ma plus mb, and v is the velocity of the center of mass, and this will be equal to m1 v1. So in this case it will be equal to m a v a plus m b v b. ठीक है? So from this equation, now here from this ma is equal to 2 times mb, what I will be doing is that I will be substituting the value of this ma as 2mb in this equation. But now here one more thing has to be taken into account, that is the these two bodies, these two particles, they are moving towards each other. That is, if this is a particle A and if it is moving towards, let us say this is a particle B and this is moving towards A and A is moving towards B. So if at any instant the velocity of the particle A is V, and if it is taken as positive, then the velocity of the particle B, since it is moving in the opposite direction, will be taken as negative. Okay? So here the velocity of the particle A is V and here the velocity of the particle B is 2V. So this velocity, if I am taking the velocity of the particle A is positive, then I have to take the velocity of this particle, that is B, as negative. So in this equation, I will be using this concept, that is in this equation, that is MA. So I will be using this concept here. So what I will be doing is I will be substituting the value of MA as 2mb. So this will be equal to 2mb plus mb, that is equal to 3mb. And 3mv into the velocity of the center of mass, and here ma is equal to 2 times of mb. The velocity of the particle A is v, and I have taken it as positive. So if this is positive, then the velocity of the particle will be as negative. Now this will be equal to mv, and vb is equal to 2v. Okay? So this minus here, this will be minus because the velocity of the particle B will be negative if the velocity of the particle A is positive. So from here, the velocity of the center of mass will be equal to 2 mb v minus 2 mb v, and here I am writing this velocity of the center of mass as cm, let us say. So the velocity of the center of mass will be equal to divided by 3 mb, and this will be equal to 0 because 2 mbv minus 2 mb, this is equal to 0. So the velocity of the center of mass is equal to 0, and the correct option is D. So in this question, the most important thing was, first of all, that we were supposed to find the relation between the mass of the particle A and the mass of the particle B, and the second step was that we have to use the equation for the velocity of the center of mass. So by using these two points, or you can say that these two concepts, we were able to find the velocity of the center of mass, which is equal to 0, and the correct option is D, that is 0. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question again, and the topic will remain the same, that is the motion of center of mass. So till then, have a nice day, bye.